Hello, everyone. Welcome back. This is college algebra. This is business calculus, section 1.5 we're going to be going through. And we're going to be solving quadratic equations. So this is quadratic equations. Quadratic equations of the type here. And when we say plus, that doesn't necessarily mean, plus. It means that it could be, if b is negative, then it's minus, right? We're going to talk about the zero property product. Zero product property, sorry, I'm saying the wrong, zero product. Which says if a times b, well, let's use different letters. Let's use, if m times n equals 0, then m equals 0, or n equals 0, or m and n equals 0. And we are definitely going to use that for our first example here. So question 1, we have solve an equation x squared minus 7x equals 0. In this case, I can actually factor the greatest common factor of an x out. And you can see we have the zero product property right there. I have x times x minus 7 equals 0, which means x equals 0 or x minus 7 equals 0. Oops, wrong button. So x equals 7, minus 7. So I'm going to add 7 to both sides. So my two answers are here and here. And they do ask you to separate them with commas. This is my open math asking you to do this. So question 2, we're going to have to do full-on factor. Before I do anything, I need to get the whole thing equal to 0. And a classic way to do this is to take a times c, put it up top, and b down below. And to be clear, a in this case is 1. That's the 1 in front of the m squared. B in this case is the 6, and c in this case is the 8. So if I use my, what's called a diamond problem, 1 times 8 goes up top, and down below is 6. And now I need two numbers that when I multiply them, I get 8, and when I add, I get 6. That's going to be 2 and 4. And now we have our zero product property again. And here are our two solutions. Now, in this case, for question 2, a was just 1, which made it relatively easy. Now that a is not 1, for example, in question 3, what I'm going to do is I'm still going to set up the diamond. Up top is going to go 12 times negative 6. That's going to be negative 72. Let's change colors a bit. Negative 72. Down below is the 1. So I need two numbers that when I multiply, I get negative 72. And when I add, I get a positive 1. And that's going to be 9 and 8, negative 8. And what I'm going to do is I'm going to take that 12 in front and I'm going to put everything over that 12 that I just got. And that's going to reduce to negative 2/3 and a positive 3/4. So I'm now claiming that the 12z squared plus z minus 6 equals 0 now factors into x plus 3/4 and x minus 2/3. Which means I now have the zero product property again. So there we are with our two solutions. And so negative 3/4 and a positive 2/3. Now we have to divide those by 12 when we did the diamond problem up there, because that number is something other than a 1. And you can notice that if you look at the diamond, we have the 3/4 and the negative 2/3, but the answer is exactly opposite signs. That's the same as above. When we ended up with the m plus 2, m plus 4, notice that our answers were negative 2, negative 4. All right, so now we are to a place where we cannot factor. So we're going to use something quadratic called the quadratic formula. And it says that to solve for x, we're going to get negative b plus or minus the square root b squared minus 4 times a times c, all divided by 2 times a. And for question 4, a is negative 8, b is negative 15, and c is positive 6. So let's see what we get. Be careful with the double negatives. You gotta be really careful. Also, when you square a negative, we get a positive value. And let's crunch all that together. See what we get. So 15 squared, and that becomes plus because of the minus minus, 4 times 8 times 6. This is 417. And all over negative 16. So let's see what we get when we dump that into a calculator. So 15 plus the square root of the 417 divided by negative 16. So I'm getting negative 2.21. We'll go to 3 decimal places. So 1, 4, that's going to round. Let's do the same thing, except now it's minus, divided by negative 19, 8. Oh, I did 16. Yeah, 16. So I'm getting a positive 0.339. And it says at least 3 decimal places, so that's where we should end up with that. Not too bad, I'm hoping. We're on to question 5. So we're considering now, instead of dealing with just a quadratic equation, we now have a quadratic function. And I'm going to draw the picture just so we have an idea of what it is that we're looking at. Let's make it a little bit smaller. All right, so the smallest x-intercept, so this is the intercepts for the x-intercepts. So when y equals 0, in other words, x squared minus 3x minus 4 equals 0. That's going to factor. So we're going to get x minus 4 equals 0, x plus 1 equals 0. So they want the smallest x-intercept, and that is going to be the -1, and the largest is the 4. So let's put that on our graph. So we have -1 here, we have 4 here, and the y-intercept is when x equals 0. So f of 0 this is -4. So we have something like this, and our graph is going to look like this. And normally we would want to know what that point is, but at this point we don't, they're not asking for that information, but later we will learn a little bit more about that. And you can see it crosses the x-axis at the -1, the +4, and it crosses the y-axis at the -4 down there. All right, a person's systolic blood pressure is measured in millimeters of mercury, depends on a person's age in years. The equation P of 0.005y squared minus 0.03y plus 122 gives a person's blood pressure P at age Y years. Part A says find the systolic pressure to the nearest millimeter for a person of age 48 years. Okay, so this is P of 48 is going to be 0.005 times 48 squared minus 0.03 times 48 plus 122. So I'm getting that we're looking at about 132.08. And this is in millimeters of mercury, so millimeters of mercury. Cool. If a person's systolic pressure is 129.96 millimeters of mercury, what is their age? And we're going to round to the nearest whole year. So basically what we're saying is 0.005 y squared minus 0.03 y plus 122. We want to know when that equals 129.96. Okay, so what I'm going to do first is I have to get the whole thing equal to 0. So I'm going to actually subtract the 129.96. So I'm getting and I'm now going to use the quadratic formula. You could knock out the decimals by multiplying through by 1,000 and stuff. We're going to get the same answer, so it won't matter. So this is going to be y equals negative 0.03 plus or minus the square root of negative 0.03 squared minus 4 times 0.005 times negative 7.96 over 2 times 0.005. All right, let's figure this out. So let's do 0.03 squared. That's going to become plus because the -4 and the -7.96. So plus 4 times 0.005 times 7.96. So this becomes what is 2 times 0.005? 0.01. All right, and let's see what we get. Now, a negative number of years, of course, isn't going to make any sense. So I'm only going to do the positive part. And it says round off to the nearest whole year. So this is about 43 years. So 43 years old. All right. That is going to do it for section 5. Thank you all for listening. I do appreciate it.